So we're going to be talking about quadratics, everything about quadratics basically, factorizing them, specifically about factorizing them and then like pulling out information from their factored versions. So the first kind of, so by the way, what does a quadratic look like in general? It looks like this. Y equals ax squared plus bx plus c. Okay, that's a general quadratic equation.
Yeah,
Why is it a quadratic? Because you see a squared term in it. The highest power of x available is a square. Okay, so
yeah,
that is what really makes it a quadratic equation. Now, the first thing that we need to do is understand what a general quadratic equations graph will look like, okay?
yeah,
So a quadratic equation will always give you a parabola of some kind, okay?
yeah.
A parabola looks like this. It might be like this. It could also be like this, U or N shaped. So how do you check what shape it will be? By looking at the coefficient of x squared, okay?
Yeah, if it's negative, it's gonna move.
Exactly.
It's gonna be the maximum value. So it's gonna
Yeah,
like the vertex is gonna be
uh,
in the positive side.
basically. Yeah. So if A is positive, it's gonna open up to the positive side. You can think about it like that also. If A is negative, it's gonna open up to the negative side. That's the way I kind of, say it.
Yeah.
The second thing is, so right now we're talking about the general form, or maybe I don't know, it's called the standard or general form. One of the forms, let's say the general form of
Yeah.
quadratics.
Yeah.
So here's the information we can pull from it. The first thing is the A value. A value tells you what the shape will be. The C value tells you the y-intercept directly. So you can check out what the y-intercept of the parabola is going to be directly by looking at whatever this number is. Okay.
Yeah.
Number three, you can also find out the x value of the vertex. You can find the x coordinate of the vertex. Let's call it fxv. Okay.
Yeah. That's minus b over 2a.
Exactly. Minus b over 2a. So whatever the coefficient of x is divided by 2 minus of that divided by 2 times the coefficient of x
And
squared.
the x coordinate of the vertex is the line of symmetry as well.
Exactly. This is also the line
Yeah.
of
And line of
symmetry.
symmetry, isn't it like the number between the two roots as well?
Exactly. So we're going to see how to find roots in a bit. So now we've talked about how to find the y-intercept, it's C. We've also talked about how to find the line of symmetry, it's like basically this thing. But very often we're supposed to find the x values of the roots basically, right?
Yeah.
So how do we find this value and this value is the question now. So like let's call them x1 and x2. So the roots basically, right?
Basically like
Hmm.
factorize.
Exactly. So we're going to want to put our general form quadratic into some other form to be able to find the roots. There's two ways to do that. I'll show you the first one first.
But isn't that form like that's the best form to do it, the standard
Yeah,
form?
I mean, no, you can't find the x-intercepts using this form. It's impossible. Not directly. I mean, you could use the quadratic formula, I guess, by using this guy, x equals minus b plus minus b square minus
No, I mean if there's
4ac.
actual values on it, you can use it.
Yeah. No, no, still you can't because you cannot directly find the x-intercepts from this without factorizing it. So what you're saying is essentially what I'm saying, by the way. We're gonna factorize this guy, put him in another form. Once he's factorized, he looks like another thing. So we call that um, the x-intercept form or something, or the intercept form. Okay,
Yeah. Yeah.
the intercept form. So what happens in the intercept form is that the quadratic becomes something like this: x minus x1,
Also called the root form, right?
the root form. There you go. Yeah, because intercept is x-intercept is the root form
And
also.
with that form you can't find B and C.
Yeah, exactly. You'll have to open it up. Good. So let's figure out how to put a general form quadratic into this form. The method I like to use is called splitting the middle term. Are you familiar with this?
Yeah.
Okay, so let's do one quick example. So I'm gonna make up a quadratic, for instance, let me think. 2x
Splitting the
plus
middle
1.
term from the name, I'm not really familiar with it, but
Okay, it probably is called something else for you, but basically the idea is that we have a quadratic and we want to basically factorize it so that it looks like that instead. Okay,
oh yeah.
so okay, so
So
let's look at how we can do that, right?
yeah.
So splitting the middle term, right? So we're gonna do exactly what it sounds like. We're gonna say that let's take the minus 5x and split him into two parts.
Mm,
These two numbers need to be filled by things that follow two rules. Rule number one, they have to add to negative 5x. The thing we broke down, of course, they have to add back to become that thing.
Multiply to -6.
Minus 6, exactly. So they have to multiply.
So it's -3 and 2.
Exactly. A lot of people get confused and they're like, oh, they have to multiply to -3. No, they have to multiply to the product of these two guys together, which is
Yeah.
negative 6.
But
Negative 6x squared if you want to be more complete.
-3 and 2 do not add up to -5.
They don't. So which numbers do? Which numbers would add up to -5 and multiply to -6?
There's -3 and -2.
No, they wouldn't multiply to -6, would they? They would multiply to
Oh,
6.
sorry, it's 1 and -6.
There you go. So we should use -6x and 1x because they multiply to -6x squared and they add to -5x, right?
Yeah,
So we should put the -6x here and the plus 1x here. Now
yeah.
that we've done that, the next step is sometimes easy to forget. Factorize the first two things, factorize the last two things separately. What can I factor out of the first two things?
2x,
2x. What's left inside?
x and -3.
Exactly. What can I factor out of the second two things?
Just 1.
Exactly. So we'll take a plus 1 out.
-3.
What do...
So then it's 2x plus 1, x -3, and
There
then
you go.
or 3 and -1.
No, 3 and -1, no. So this is your quadratic, right? Now, first let's study this guy before we talk about the roots directly. The first thing is there is a coefficient of 1 sitting outside. That's the a value, okay? So this guy tells me that it's a U-shaped graph, okay? Now,
But how do you know there's a 1 outside?
I mean, because when there's nothing, there's 1, right? If there was a 0, everything would just be 0, so it can't be 0. So
Okay.
there's a 1 outside, okay? So this is what tells you that you have a U-shaped graph. That's one thing you can pull out of this. The second thing you can pull out are the x-intercepts. That was the reason we basically put it in this weird form anyway. So for the x-intercepts, remember, y is 0, right? When you're looking for the x-intercepts, you have to plug in 0 for y. So you end up with 2x plus 1 and x minus 3 equals 0 because you've put 0 for y. Again, why am I doing that, by the way? Because on the x-axis, y is always 0. So every x-intercept will have a coordinate of some x value and 0 as the y value. Okay? So that's why I'm plugging 0 for y and solving the equation. I end up with this, and this is an interesting situation now. I have two things multiplying together, and they equal 0. The only way for two things to multiply together and equal 0 is if one of them was 0 themselves, because no other two things that are not 0 multiply to become 0, right?
Yep.
So the first one tells me that x is -1/2 by subtracting 1 on the right side and then dividing by 2. The second one tells me that x is 3. So I get two answers. You will always get two answers. They may be the same, but you will always get two answers. Okay? So
Yeah.
now you've found the root of your the x-intercepts or the roots of your quadratic.
One question.
What's up?
What if the equation there's only like it cannot be factorized? What would happen then? It wouldn't be a parabola, right?
So you mean what if the equation could not, like you couldn't find any two numbers that do this?
Yep.
Good question. We'll talk about that in a bit. So this obviously depends on us finding something like this. If this doesn't happen, if you cannot find two numbers that follow both the rules required, then you're stuck. You cannot use this method at all. But regardless, let's discuss that in a bit. So you end up with -1/2 here and 3 here. Since it's a U-shaped graph, you can safely draw it as the most perfect U that you can draw, right? I couldn't have done better than that. And that's it. The unfortunate thing is this is all you can find directly by using this form, okay? However, of course, if you do a little bit of handiwork, you can find out some other things. For instance, extra stuff from this form. So the first thing you can find out is you can find the vertex x value, which is also, as you said earlier, the line of symmetry or the axis of symmetry. Basically, the line that is going directly through the center of the parabola. Okay, how do you find that? As you said, parabolas are perfectly symmetric around their center, right? Around their vertex x value, which means that the distance between the x value of the vertex is directly between -1/2 and 3. So all we gotta do is find the midpoint of -1/2 and 3. And the easy way to find the midpoint of any 2 points is just to add them and divide them by 2.
Yeah.
It's simply going to be -1/2 plus 3, all of this divided by 2. Let's see what happens. -1/2 plus 3, I need to first multiply the 3 by 2 at the top and 2 at the bottom. And then I can add the tops. 6 minus 1 is 5,
What do you get? 6 over. Oh, yeah, 3.
because I multiplied the top and the bottom by 2.
Yeah, 3.
And that leaves me with 5 over 2 over 2. Since 5 over 2 divided by 2, that's what we have, is the same as 5 over 2 times 1 over 2. As I said, you can convert a division to a multiplication by flipping the second thing.
Yeah.
This will give you 5 over 4. So your axis of symmetry is x equals 5 over 4. As I said, by doing a little bit of handiwork, you can find out the x vertex value, the x
Yeah.
coordinate of the vertex.
So you can
Okay.
basically find anything like
Yeah, you can, obviously, if you're smart enough, you can find everything about the parabola. And the other thing you can find out is the y-intercept. Now the thing is, if it was opened up, as I said earlier, if it was opened up like this, the y-intercept would just be this number.
But the
But
y-intercept is just like you either use the standard form or you just expand like the
yeah, that's what I'm saying. So you don't need to expand. This is what a lot of students do, and they waste time. To find the y-intercept, remember that just like when I was looking for the x-intercept, I plugged in 0 for y, right?
yeah,
When I'm looking for the y-intercept, I need to plug in 0 for x.
yeah,
Similarly, and again, the reasoning is the same. If I'm on the y-axis, my x value is 0, so I plug in 0 for x. And thankfully, 0 is my favorite number because you can just plug it in into any equation, and it makes life so much easier, because if you plug in 0 here, you will get 0 plus 1 and 0 minus 3, which is -3. So in one simple line, without opening anything up, I found the y-intercept. So we've also found now the y-intercept value. Isn't life the most perfect thing in the world? This
yeah.
was such a smooth way to find everything you need about a parabola just by using this form. Of course, a little bit of extra work, but this is my favorite form to work with because it tells you the x-intercepts. And
Can
by
you
doing
can you
uh-huh.
find stuff without knowing the equation? Just maybe like the vertex and the roots, for example.
Good question. So we'll look at that kind of situation in a bit. You're saying that, for instance, if someone told me just that these are the x-intercepts and this is the vertex x value,
Yeah,
can I find the equation of the graph?
yeah,
I will need one more thing. This is, by the way, a side discussion, but let me just explain it. Look, when someone tells me the x-intercepts, I know how wide the graph is, right?
yeah,
However, just because you told me that this is where the graph intersects doesn't tell me whether the graph looks like this, or even this. You need to tell me something related to y also. I need some y thing, either the y-intercept or the y value of the vertex. I need something related to y. Otherwise, I cannot pin down and say it's specifically this parabola, because who is to say that it's not this one? It also passes through those 2 points. You see?
yeah.
So we'll look at a question like this later, but understand that I need something related to y along with something related to x also. Okay? I need two things. So this is all you can do with the roots form. Is this clear?
Yeah.
All right. And the final um, form that you need to know about, which has recently become my very favorite form, is the completed square form,
Vertex, right?
the vertex form, exactly. Also called the vertex form. Okay. Now, um, there are two ways to understand this. Both of them lead to the same result. But I want to explain to you why we can factorize something in this way. Look, do you know that a plus b whole squared equals a square plus 2ab plus b square? You know that, right?
Yeah.
Okay. Now, for instance, if I have x plus 4 whole squared, I will get x squared plus 8x plus 16, right?
Uh-huh.
So that means that if someone gives me something like, for instance, x squared plus 10x plus 25, I should be able to kind of reverse engineer this by realizing that since this guy, if I half him, I get 5, and if I square 5, I get that, right?
Yeah.
So this tells me that this whole thing is just x plus 5 whole squared, because it follows this rule. If you half this and square it, you will get b squared. You see?
Yeah.
But it only happens in a perfect square. For example, if the same thing becomes x squared equal x squared plus 10x plus 100, then I'd be in trouble, because if I half 10, I get 5, but if I square 5, I do not get 100, do I? So this
No.
is not equal to x plus 5 whole squared anymore, because I need this guy to be the square of half of this, right?
Yeah.
If it's not, then it's not a perfect square. But here's what we do. We do a clever thing. What we do is we say that since I have a 10 here, that means I need the square of 5 over here, right? I need a 25 over here. So what I do is I say, okay, let's put a 25 there. But to keep the equation the same, let's add 75 extra on the side, because ultimately this is still 100, isn't it?
Yeah.
But by doing this, by spreading the 75 out, I have created a completed square over here. X squared plus 10x plus 25 is indeed x plus 5 whole square. But I have a 75 left over because this guy didn't fit in. I needed 25 here, but I had 100. You see what I mean?
Yeah. Yeah.
So I've completed the square. Let's try another example similar to this one. So let's say you have 18x plus 100. What do I need over here? You tell me.
Uh, so you, for you, that form won't work.
No. I mean, let's assume that it doesn't, because this thing, the
Yeah.
completed square form, works every single time. There's no case it doesn't work. Okay. So let's just force ourselves to learn this.
Yeah. So then I divide by 2, which is 9.
Okay, so what do I need over here?
Then I need a 9 squared.
Sorry, 9 squared, exactly, which is 81. So I need an 81, but I have 100. So what should I do? I should write down x squared plus 18x plus 81, but to make this a complete 100, I need to add what?
Add 19.
Exactly. So I have a 19 here, so that the whole thing stays 81, 100.
Yeah.
But I have completed the square.
Then it's not fully factorized, right?
But now it is.
But if I add the 19, it's
Ah, so yeah, it's like depends on how you say like what you call factorized, but this is called the completed square form. Like it's not, yeah, it's technically not fully factorized, but this form is very useful. It can tell you almost everything. Okay,
so
and
when
it
should
works
we
every
use
time.
this? When should we
Mhm.
use it?
Yeah, yeah, I'll tell you that too. But for now, do you understand how to use this method?
Yep, yep,
Okay. But now, before we move on, I want to tell you a shortcut that you can use to directly complete the square on anything. Okay?
yeah,
X squared plus bx plus c, for example, if you have this, okay,
yep.
any b, any c, doesn't matter. First thing you do is realize that whatever you have here, you always end up with half of that over here, right?
Yeah.
So you have x plus the half of b, okay?
Yeah.
And then now, because if you open this up, you're going to end up with b squared on the right, right? So we have to subtract that and then put the c back, okay?
Yeah.
You can use this method directly, just copy paste it, and you can complete the square on anything immediately. For example, you have x squared minus, I don't know, 124x plus 1000, right? This is hard to do using that method, but if we use this one, can you walk me through what this would be?
Um, so 124 divided by 2, which is sorry, just 62.
Uh-huh. So what do I write?
62 squared. So then it's x squared plus
No, no, no. Use this formula that I wrote down. Just
x
yeah,
plus
x minus now, right? Because you have a negative
yeah,
here.
x minus 124 over 2 squared um, plus,
Minus.
but no, it's multiplying.
No, no. This is always minus. Because this is always going to be negative. This depends on this, but this is always negative. Okay?
All right,
Yeah.
so. Yeah, just negative 124 over 2 squared plus 1,000.
And that's it. So you can just simplify this, clean it up, but you're done. 62 whole squared
Yeah.
minus 62 squared plus 1,000, and that's it. That's the completed square form. Of course, you can add these up and make it simpler, but this formula is super useful. All my students use it all the time. It skips so many steps for you, and you can readily factorize any quadratic in the world by using this, because this will never fail. It will always work.
So
Unlike this method,
when should we use this again? Did you say?
I'll explain that in a second, but for now, this method requires that this works, that there is some pair of numbers that follow both the rules required. However, this guy doesn't have any predisposition like that. You can just use it always. It has no restrictions, no nothing. Okay.
Yeah.
Now, let's talk about why this is so useful. I'm going to teach you by example. Let's use a random, like, let's say x squared minus 18x plus 100 equals. So this is y equals this, okay? Let's factorize it. It's going to be x minus 18 over 2 whole squared minus, again, 18 over 2 whole squared, which is 81, and then plus c, okay?
Yeah.
And that's going to be, so I'm going to simplify this. It's going to be x minus 9 whole squared plus 19. Okay. I'm actually realizing that I've made a mistake. I shouldn't have done this because this is positive. It's going to give me issues later. So let's make all of this negative, and it's going to give me 181 minus 181. Okay. Um, maybe I can make the number even better. Let me think. Minus 19, let's say. Minus 19, which makes it minus 100. That's a good clean number. Okay, so this is my factorized version. Now, what's the use of this? Okay, first of all, again, remember that whenever you don't see a number, there's a 1 sitting here, okay?
Yeah.
The 1, since it's a positive number, means that it's a U-shaped graph. This number, ignore the minus, okay? Just the number. Like what I mean is, if this is minus 9, okay? So I
Yeah.
want to do this very carefully. If this is minus 9, that means that the x value of the vertex is 9. So opposite sign, okay?
Yeah.
Not minus 9, but 9. Since this is negative 9, the x value of the vertex is 9, okay?
Yeah.
And similarly, since this is minus 100, the y value of the vertex, what do you think it is?
So y value, since that is 9, the y value is
No,
so we have to substitute.
no. So the x value of the vertex is simply this number, okay?
Yeah.
Oh, sorry, the opposite sign of this number. So if this is minus 9, the x value of the vertex is 9. And this number is directly the y value of the vertex, okay?
And is there any way, imagine if they give us the standard form, if
Uh-huh.
how do we convert it in the vertex form?
So what do you mean the standard form? This form.
No, the a like the y is equal to ax minus bx uh, plus c.
Ax squared minus b. What do you mean? This
Wait,
form?
uh, wait, let me go to your mouse.
Okay.
Which form?
So are you talking about this one?
Yeah.
No, but that's exactly what we had. See? In the beginning, that's what we have. This is the ax squared minus bx plus c form. Like, this is the standard form.
Oh, yeah.
Yeah, and that's what I showed you, how to do it for the standard form. Okay?
Yeah. No.
So now, remember, the main takeaway is that this number is the x value of the vertex. Sorry, the opposite sign of this number is the x value of the vertex, okay?
Yeah.
And this number itself is the y value of the vertex. So don't mix this up. X minus this number, and this whole number is the y value, okay?
Okay.
So that's the first thing you can find out from a vertex form, okay? Now we also, so that's it, right? We can only find out the shape and the x value, like the coordinate of the vertex. But what about the other things? Okay, so everything we know so far is this. We know that the shape is u, and that the x value of the vertex is 9, and the y value is minus 100.
Yeah.
So the vertex is down here. But we don't know what the graph looks like. I mean, we don't know what the x value of the, what the x intercepts are. We don't know what the y intercepts are. So we need to find those now. So how do you find the x intercepts using the vertex form? Let's find out. Remember, to find the x-intercepts, what is 0?
Huh?
To find
What?
the x-intercepts, what is plugged as 0?
The y.
Y, exactly. So we have to take the equation we got and set it equal to 0. Okay.
Yeah.
Now, add 100 to both sides because you're solving for x, right? So add 100 to both sides. Square root both sides. So you end up with the square root of 10 is plus and minus 10. If you forget plus and minus, your quadratic will give you one answer only, which is impossible because quadratics always have two answers for
Yeah.
root, okay?
Yeah.
And then add 9 to both sides. So you got 9 plus and minus 10, which gives you two answers, either 9 plus 10 or 9 minus 10. So you
Yeah.
have your two x-intercepts from here. So you got 19 and minus 1,
Yeah.
and you get this, okay?
Uh,
Now, what about the y-intercept? How can you find the y-intercept? You tell me. How do you find the y-intercept?
yeah, I substitute
What
the x.
for? What's the value of x?
It's either 19 or
No,
minus
no,
1.
no. That's the x-intercepts. For the y-intercept, you have to plug in
Oh,
x
sorry,
equals
just 9.
0. No, 0.
Oh,
X-intercept. We're finding the place where the graph hits the y-axis.
oh yeah.
So we're trying to find when the what the y value is when x is 0. So we take our function again and we plug in 0 for x. So we have x minus 9 whole square minus 100, which gives you 0 minus 9 whole square minus 100, which is 81 minus 100, which is negative 19, which is right there. So see, you can find out the y-intercept, you can find out the x-intercept, you can find out the vertex values, you can find out the shape. Everything can be found out by using the vertex form. And this is honestly my favorite form at this point. For the sole reason that you can complete the square, you can factorize any quadratic in the world to look like this. Every single quadratic. There is no restriction on it. Okay?
Yeah.
Now, let's do one more example for vertex case, vertex form, because there is one thing I haven't explained yet. It is, now let me show you. Every single time I showed you the completed square form, do you see anything common between all of these questions? Look at the starting situation very carefully. Is there anything common between all of them?
Um,
Look at the coefficient of x square. What is it in each of them?
of x, it's always 1.
Exactly. So I've been lying to you. Every single question I've done it with a coefficient of x square being 1. What
Yeah.
if it's not 1?
Then you
What if?
just multiply it to see.
Not exactly. So let's, for example, do an example, right? Y equals 2x squared minus 36x minus 100, for instance, okay? Or 200, let's say.
Yeah.
The first thing you gotta do is remember, this is the most important thing for completing the square. To complete the square, the coefficient of x squared has to be 1. It cannot be anything except 1, okay?
Yeah.
So this number has to be 1. It cannot be anything else, okay? So here's what you do. You take a 2 out and factor it, basically. So what is left inside if I factor out a 2?
X squared minus uh, 18, and then minus 100.
Exactly. So it has to be 1, not minus 1, not 1 over 2, not anything, just 1, okay? So whatever you have here, take it out of everything, okay? Be
What if
very
it's a
careful.
fraction?
Good question. Or what if it's not common? What if I couldn't take a 2 out? Here, a new revelation has come to a lot of my students. The thing is, you don't need all of your numbers to be divisible by the thing you're factorizing. That's a lie, okay?
Yeah.
Look, when you factor something out, what are you really doing? How do you know that 36x will become 18x when you factor out a 2?
You're trying to find the two roots.
No, think about it again. So how do you know that when I take the 2 out, 36x will become 18x?
Because after when I expand it, uh,
It's gonna be, yeah. So if you think about it a bit deeper, you'll realize that all you're doing is you're dividing 36 by 2, aren't you?
yeah.
When you take something out, when you factor something out, you're essentially dividing everything inside the fractions by what you just took out. That is factorization. Okay? We like it to be common. We like it that everything is divisible by 2, but sometimes you don't have a choice. In this scenario, for instance, you have to take the 3 out. But you can't divide 2 or 100 by 3, can you? Doesn't
No.
matter. You have to take it out anyway. 3x squared becomes x squared because 3x squared divided by 3 is x squared. 2x will become 2 over 3x, and 100 will become 100 over 3. And
Yeah.
as you can see, when you open this up, you're still going to get the same thing from before, because this is how truly factorization works. Okay?
Yeah.
Does this make sense?
That makes sense.
Okay. So let's try to complete the square on this now. Try to use the formula I wrote down. Do you remember it, or do you want me to copy it down here?
Maybe just copy it down real quick.
Okay.
Thank you.
So try to memorize this formula, by the way. Super useful.
So that's for converting from standard form to
To
perfect.
completed square or vertex form, yes. So remember, this is always negative, but this middle sign depends on this sign.
Let me write the formula down
Yeah.
quick.
And just note down for yourself that these are always same, and this is always negative.
Yeah.
By the way, be careful. I forgot these squares.
Wait, vertex form, if I want to like write it just as a formula, so then it's y is equal to
The
what?
general form, right? The x minus
Yeah,
h
the
stuff.
general.
Yeah, I'll tell you about that in a bit. I'll summarize everything in the very end, basically.
Yeah, it just wait. Can I search out quickly because I want to like make
Yeah,
note?
sure, sure, sure.
Alright,
Take your time, by the way.
okay. Oh, oh
Yeah,
yeah.
so now we're basically gonna factorize these guys. So let's try to do this one first. Try to use the formula to factorize this.
Right. So then it's gonna be x plus minus 18 over 2.
I mean, you can just say x minus 18 over 2 then, right?
Yeah.
X minus 18 over 2. Okay,
Squared
whole squared.
minus 18 over 2 squared
And
plus.
then, no, minus 100 in this case, right?
Oh yeah, sorry. I didn't.
Yeah, because it's plus minus 100, so you can just say minus 100.
Yeah.
So that's that. Now we can, of course, simplify this a bit. Let's just do that quickly.
Fine.
We're gonna have, remember, keep the 2 outside for now. X minus 9 whole squared. This is gonna be 9 squared, which is 81, right? So minus 81 minus 100, which is just minus 181, right?
Yeah.
And don't forget, open up the 2 at the end, but do not put it in the square, okay? What I
Uh-huh.
mean is keep it outside the square. You cannot multiply it inside the square like this because it's locked in by a square first.
Yeah.
And then what is 181 times 2? It's 362, I think.
181 times 2?
181 times 2, yeah. I'm pretty sure it's 362 because 180 times 2 is 360.
Yeah,
One
it's 3.
more, yeah. So now, using this, what is a? 2. What is the x value of the vertex?
Uh, so now we can. Oh, it's y value or x value?
X value.
9.
Exactly. Not minus 9, but just 9. And what is the y value of the vertex?
Wait, is it always positive or just the
No,
opposite?
no,
Like,
opposite, exactly. If it's minus 9, it's 9. If it's positive 9, it's minus 9. Okay?
and then y is it's just shit. I forgot.
This number.
Isn't that just the that y-intercept?
No, no, no. Common misconception. This is not the y-intercept. This is the y value, the vertex. Okay?
Oh yeah,
In
yeah.
in the standard form, it's the y value.
But it's k. Like the 362 is k over.
Exactly. Negative 362 though. Remember, y is the same sign, x is the opposite sign. Okay? Don't
Yeah,
mix this up. Very
yeah,
important. So this is your, but remember again, this is also not the y-intercept. In the standard form, this is the y-intercept. But
yeah.
in the vertex form, it's not. Okay? Be careful.
Yeah, and the way to convert the vertex to standard is
Just
just.
open it up. Just expand the square
Oh
and
yeah, of
clean it up.
course.
Yeah, simple.
Yeah,
So
simple.
that's it. Let's try the weird one again, the one with the fractions and stuff. Let's put this here so we can do it together. What do you think?
Jeez. So then Yeah, so then it's x plus 2 over 3 over 2
Okay, whole squared.
squared minus 2 over 3 over 2 squared negative, and then plus 100 over 3.
That's it. So now you should know that. What is 2 over 3 over 2?
2 over 3 over 2. That's 1 over 3.
Exactly, the 2's cancel out. If you want to be a bit fancy, you can show your working like this, and then say that I can convert the division to a multiplication by flipping the second fraction, and then cancel out the 2's and show it's 1 over 3. But don't be fancy. Save time. So this is 1 over 3, right?
Yeah.
This is 1 over 3, this is 1 over 3. So let's rewrite it. So we end up with x plus 1 over 3 squared minus 1 over 3 squared, which is just 1 over 9, right?
Yeah. Yeah.
1 over 9. And then over here we have 100 over 3.
Yeah.
So let's clean it up further. We have x plus 1 over 3 whole squared. We can multiply this and this by 3 to make the denominators the same so we can add them, right?
Uh-huh.
Because we're going to have 300 over 9. So 300 minus 1 is 299 over 9. Now, another common issue that everybody has is they're like, oh, okay, so now I can tell the x vertex value is minus 1 over 3 and the y vertex value is 299 over 9. But that's wrong. You can't forget to multiply the 3 with this and this. Okay?
Uh-huh.
So you can't directly say it. You have to like open up the 3 first. The 3 still needs to be inside. Okay? But remember again, as I said, do not multiply the 3 with the whole square. Okay? Just keep it outside like this. And
Yeah.
then multiply the 3 with the 299 over 9. What is that going to be?
2 over 9 over.
No, no, 299 over 9.
Yeah, that's about. It's just. I don't know.
So the 9 and the 3 can cancel out, right?
Oh, times 3. Yeah, yeah. So then it's 299 over 3.
Exactly. So we end up with this. This is your final answer. Now, from here, can you tell me what the x value of the vertex is?
Yeah, yep. So it's negative 1 over 3.
Exactly, because it's the opposite sign of this. And what's the y value of the vertex?
It's 299 over 3.
Perfect. And that is it. End of story. Okay. So
Yep.
now, just as a summary and to remind you of what the standard form of the vertex form looks like, the vertex form will always end up being in this kind of form.
Yeah.
Okay. From this form, A being positive will tell you that it's, U-shaped. A being negative will tell you that it's V-shaped. Number one.
So for what values would you say is the best to convert a standard form to vertex form?
I personally just do it for all quadratics at this point.
So it's
Because,
better than root as well, you would
yeah,
say.
I mean, the thing is, if you only want the x-intercepts, go for this. Okay.
Which one?
Because look, the root form, right? It directly tells you where is it?
Yeah,
Yeah. The root form directly tells you the x-intercepts. And to find the other stuff, you need to do some like, algebra. To find the vertex, you need to do some work. To find the y-intercept, you need to do some work. But the
yeah,
only issue with the root form is that sometimes it doesn't work because you need two numbers that follow these rules, right?
yeah,
But they may not sometimes they may like there might be not be any numbers that do that. But the good thing with the completing square form is the vertex form is that you don't need any rules like that. You can just force it, You can
yeah,
use this formula and just force it to happen. This formula. Okay.
yeah,
So I like this rule, but obviously in the exams, when we do some exam practice, you will see that sometimes they specifically tell you to use a specific form. Okay, anyways, so over here, the h value will give you the x value of the vertex, and the k value will give you the y value of the vertex. Now be careful, as I said, even though this says minus h, I am using h, okay? Opposite signs.
yeah,
But again, also be careful that the y value is not opposite signs, it's directly the same thing, okay?
yeah. Understood.
So that is the y value of the vertex, okay?
Yeah,
And that is basically everything you need forever, basically, about quadratics. You will never need to learn anything new about quadratics beyond this, like ever. I mean, until university, even after. This is
Yeah.
all you need. Okay. As long as you understand all of these ideas and practice them enough, I'll send you some homework after the class for this. And in the next class, we'll be discussing how to create a quadratic equation when you are given some information about the quadratic. For example, if you're told that the x-intercept is this and the y-intercept is this, can you find the quadratic? I'll explain how to solve those questions from the actual exams.
When is our next class? Like,
Yeah, we gotta figure that out now.